And okay, I'm starting with a little bit about me. I'm developing software for about 15 years, maybe even more. And I started with the Commodore C64, and later I moved to the Amiga and to MS-DOS later on. And today I'm a full stack developer specialized on Windows Azure and the related technologies. I'm married and I love all sorts of Marvel stuff. I have a company in Las Vegas, and the company is called Xtrip LLC, where we produce all kinds of Windows Azure and Azure mobile stuff around the clock. And my main product is App Additives. It helps Windows Phone developers to market their app. And yeah, maybe you've seen that logos on some page somewhere, or maybe you are using already the service. Please contact me on Twitter at AwesomeDesigner and visit my blog. You will find there lots of stuff about mobile services and how to work with mobile services. Yeah, asking me questions, that's really nice, and I like questions. But if it's possible, maybe we can do a Q&A afterwards, after the presentation. I will try to go as quickly as possible through all the stuff, because we have lots of things to see, lots of new stuff to learn. And I've prepared already a project, and it's working. I've done that in the last 3 hours. That was quite interesting, but everything works, and I will publish the source code, I will publish the presentation, I will publish everything else after the screencast, maybe 2 or 3 days later. So if you have questions, ask me, but I think it's better when we do a Q&A at the end of the session. So let's dive in straight into Windows Azure Mobile Services, the .NET backend. What you see here on the screen is a schematic of the basic features that are offered by the .NET backend. So in the center you can see the mobile services itself, and the mobile services are hosted on Azure. This means you need to have an Azure account, or at least a demo account or a trail account on Azure to test all of this. If you are a BizBug member or you have an MSDN subscription, you can have up to $150 of money you can spend for free on your Azure subscription. As you can see, the mobile services the managed mobile services have, on the backend side, they have SignalR. SignalR is a near real-time service that allows you to send messages to, I would say, some kind of subscribers. They subscribe to the hub, and you can send out these messages. These messages can be received on a mobile device, in a simple WPF application, in a console application, on your website, and, for example, in a Windows Store app as well. So SignalR is, it doesn't ask for much to be run on a platform, and you will see how to implement that in mobile services in the .NET version. And then we have the database part. Most of the time, the people will use SQL Server as the backend, but you can use also MongoDB or any other kind of database that is supported, for example, by the Entity Framework. And what you can do also is you can utilize table storage to save your data. And this is very useful if you have tons of data, millions of records, or maybe more. And Azure Table Data is the right thing to do if you want to save lots of data, because it's very cheap, and it's much cheaper than the SQL Server. So you could use this solution as well. And then we have the next part, which is authentication. And as you can see, you can enable very easily all kinds of social logins for your mobile service. You have the Microsoft account, you have Twitter, Facebook, Google, and you can even write your own extensions, for example, to use LinkedIn, or for example, to have your own authentication provider, which is custom which is a custom implementation. And for enterprise apps, you have also the possibility to use Active Directory authentication. And the next interesting part is the service bus. It is also a part of the mobile services.NET backend. And one feature of the service bus that is used are the notification hubs. The notification hubs are able to distribute millions, hundreds of millions of messages to your users worldwide. And through the basic scalability feature of Azure Mobile Services, so the basic tier is not scaled out, but the standard tier, starting from the standard tier, you will have a basic scale out on the notification hub, and the more users you have, the more instances will be fired up, and that happens all automatically in the background. You don't have to do anything for that. From my experience, what the main problem is understanding mobile services.NET or the .NET backend is that many developers, especially Windows Phone developers or developers that don't come from backend service background or maybe from an ASP.NET background, don't understand the basics of Web API, for example, or ASP.NET. And therefore, I like to introduce you a little bit into the matter, but not too long, because we have lots of source code to check, and I want to give you a little bit of an idea how the whole development stack, or how the features of what are the features and what are they made of, what components are used in the .NET backend, so that you can make yourself a picture and you can decide instantly where to go and which information to look after. So that's very important. Okay, so let's first talk about OWIN, Katana, and Web API. So OWIN is a standard. It's an open web interface for .NET. We read the graphics from bottom to top. And you can see that Katana is built on OWIN, and it's an open source implementation of the OWIN standard. You have two possibilities and even more possibilities, but those are the most used possibilities. You have IIS hosting or you have self-hosting. And later when you see the controllers inside the sample project, it will all make sense. You have those API controllers that perform the CRUD operations. CRUD operations create, read, update, and delete. This is an abbreviation that comes from the database sector, which was transported to the REST API. You have those CRUD operations to insert your data, to update your data, and so on. And on top of this self-hosting part, which is the host, you have ASP.NET Web API, which is a REST framework. And you can build very fast and very quick, highly scalable applications using Web API and publish that, for example, which is another scenario, as a web role on Windows Azure. So the Azure Mobile Services incorporate all of that and more. And as you can see, there's another part, which is the Entity Framework. And the Entity Framework is used to access and modify your data. The Entity Framework is an object relational mapper. This means that you have a relational database, but you map plain old objects, this means Popo objects, to your relational database, and this is exactly what the Entity Framework does. And Mobile Services.NET makes heavy use of that and has also some kind of special implementation with a special layer that is between all of that. Those are the DTO objects. And the main purpose of this layer in Mobile Services.NET is to create JSON everywhere possible. Why JSON? Because JSON is a highly used standard, web standard, and you can use it on any kind of platform, starting from Linux to Windows, iOS, Android, and so on. And therefore, the main goal was to have JSON everywhere. But you will see that later on. And yes, this is a basic overview of the entity framework and what it does. You can see at the bottom is the database. On top is the managed service hosting OWIN. And you have the entity framework in the center and all the model classes. So we have one table model class, which would be, for example, a customer class, and we have one table model class, those POPO objects. That could be, for example, an order class or an order table, and so on. And the DB context uses all these POPO classes and creates something called DB sets to insert and update data. And underneath the DB context, there's plain old ADO.NET that is executed using the data provider, the System Data SQL client. This means that you utilize the POPO objects, entity framework context, entity framework, excuse me, not context, converts your calls that you do in your code and create SQL statements, and those SQL statements are passed again to ADO.NET and executed on the database. So these are the basics, and I can only, I highly suggest that you take your time and learn about entity framework, and that you learn about Web API as much as you can, because you will need it in the managed backend. And a good place to do that is, of course, the Pluralsight site, where there are excellent tutorials about entity framework, for example, from Julie Lerman. Yeah, those are really excellent. And many, many other tutorials about Web API and so on. But I will create an extensive list of links also. I think about 200 links where you can go and that you can use to check out the base technologies that are used here, and including all the tutorials that are really relevant on the Windows Azure side. Okay, so when you create a mobile services.NET project, those are the main components that are created and are used. So another thing you need to know about if you want to leverage many other features that are offered by mobile services.NET is you need to know about dependency injection and what that is and how it works. So this will be a next thing to learn if you don't know what dependency injection really is. So if we take a look at this picture you see on the top, you see again the OWIN and Web API hosting and configuration stuff. I will show you later what kind of files are responsible for that, where to look and where to do your configuration, and where AutoFac is used, what the controllers are. The controllers offer us the functionality to execute any kind of functions or operations we want, not only functions or operations bound to databases. You can do anything else. You can create also custom controllers, and those custom controllers can call other web services or do any kind of stuff, anything you want. And we have the model that contains the entities, and I will show you that in code later on, and you will know instantly what it does. And the DTOs I've talked before about. Those DTOs are between the entity framework and the Azure Mobile Service. Then at the end there's the database, the SQL server. It could be also MongoDB or something else. Then you have the push notifications that are connected to the notification hubs. that are part of the service bus. And then you have Signal R, this real-time framework, or near real-time framework. It's not 100% real-time, but it's very fast and highly scalable. And it's again connected to the service bus. If you upgrade from the free tier to the standard tier, then the scaling functionality will be added. And you have, last but not least, you have the scheduled jobs that you had before also in the Node.js backend or the JavaScript version of the mobile services. And yeah, but those work a little bit differently. I've not added any custom scheduled jobs so far because we have lots of code to go through and the basic project structure and more. So I don't know if it will be enough, to be honest. So on the next page, this is something that I would like to recommend to you. So when you create a new managed service, you will have the mobile services project. I would create one solution that only includes the mobile services project, one solution that only includes the client app, and a separate assembly for existing databases. This is a completely different approach than the approach that is used by the Windows Azure Mobile Services team to map existing databases, for example. Yes? I cannot hear you. There's some strange noise now.
Come on,
Yeah, so we've got that Illich, yeah.
Yeah, what's up?
Yeah, it was just somebody unmuting the microphone. I didn't spot them.
Could they hear me until now or not?
Yeah, you're okay now. Go on, continue.
Okay, sorry. And one project that is that only contains the client focus in a portable class library. And those classes you will use to execute queries against the mobile services using the mobile services client. And therefore, if you, for example, create a Windows Store client and a Windows Phone client or a universal app, you can include that in your project and you don't have to update all of your projects. So that's the main goal. And you will see that the solutions that I have created are exactly built like this. Just to have a better maintainability or maybe later on also better testability and everything else. Because if you put everything in one solution, first of all, it's not nice, and second, it will take a long time to load and all this other stuff. So it's really not practicable. So I don't know what other people think or do, but I believe that this is really a good approach to use. Okay. So just to clarify one thing, I will not show you how to create a managed mobile service. I have done that already, and I will show you what is important to activate, for example, the notification hub, how to do that, which commands to execute in Visual Studio, and so on. And I will not write live code now, but I have prepared an example. I have used the existing example and I have extended that example, this to-do items example, to notify us when we insert, for example, a new record into the external database, or if anything else changes, to send us notifications from Signal R, and how this is implemented in the backend, how to use it in the front end, and so on. It's a bit modified, but sorry, I believe that it will be better for you to understand it, because you can use an existing example and you can follow those steps later on in the standard tutorials that are published by the Windows Azure team, which are really excellent. And I can highly recommend only to you to read all of these tutorials that are published on Windows Azure, because they work. Even if people say they don't work, they work. So, okay, that's so much about the presentation. Now let's switch to the Azure portal. Oh my God, let me close that. And okay, some errors, but we can ignore that. And what I want to show you is, after you have created your managed.net service, you have to go to configure the push notifications. Yes, it will take a little bit of time. So I've come, and you can see that I have to enter the client secret and the packages ID. So where to get these values now? Because we will use Windows application credentials, and we will not use Windows Phone notification settings, MPNS or something, because we don't need a certificate. And if you create a universal app, you can switch and you will find a certificate, and that's the advantage. Okay, so you can copy these values if you go, yes, let me see that, to your Windows Store dashboard. Okay, and this is the app that I've created and associated with the store. I go to Edit, and I click on Services here. And then I click here on Live Services site. And you see that all of this data is available here. You have the client ID, you have the client secret, and you have the packages ID. And here's one really important thing also. If you configure the API settings, you need that to be able to authenticate the people against the Microsoft account. And there have been many discussions recently, also on GitHub, what the right redirect URL is and what the right settings are. So first of all, you have to set mobile or desktop to yes, and you have to restrict the JWT issuing here. So these JWT tokens are issued every time a user is logging in to your service, and you have a root domain here. So unfortunately, you can add only one root domain. This means that you can use it only for your mobile service or for your website, for example. But if you have a website and you want the users to log into your website using the same credentials, for example, as they do for your Windows Store app, this is not possible currently, not in this way. But the important stuff is here. So the redirect URL is your service name, your mobile service name. As you can see here, it's lidnugdemo.azuremobile.net, and then you have here to put this little piece, this little string here at the end, which is sign in minus Microsoft. And this works 100%. And it works out of the box. The documentation is a little bit unclear about that, but this is definitely the stuff that will work and will allow your users to sign in with a Microsoft account. Okay. Now back to the configuration of the hub. You can see that I have inserted here the client secret and the packages ID. And those are the values that I have copied from the settings here. You can see that. And now when you have done that, you have to choose your notification hub, and you have to go to configure, and you have to insert the packages ID again and the client secret. So if you don't do that, it will not work. Okay? It will not work if you don't do that. And at first I thought when I used it for the first time, it will create this association automatically and so on, but it's not the case. You have to do that manually, okay? So when you have finished this a little bit of configuration. Usually when you start a new app, you can download this app. This is what I have done, and I've extended this example. And later on, when you download the examples and everything else, yeah, you can orientate yourself on this example. And what you need to do next on the identity tab is you have to insert all the data that you need, for example, to authorize the users against a Microsoft account, or Facebook, for example, or Twitter, or Google. Or, like I mentioned before, Windows Azure Active Directory, which is very nice options for the enterprise and side-loaded apps and so on. But we will not use that here. We will use only the Microsoft account for now, just to show you how it works. Okay. So what I said before, if you go on the Scale tab, you can see that we are in the free tier currently. But as soon as you switch to standard here, you will get your automatic scale out for push, okay, and for signal arm. So that's quite interesting. And yeah, the logs, that should be familiar to everyone else who has created already Azure Mobile Services. This warning and this error was generated before, but it's not anymore there, and these warnings can be ignored for now. Please remember that the managed.NET backend is still in preview, and it's pretty stable, but yeah, it has some problems, but those problems are very, very small, so they can be ignored. Okay. So what I said before, when you create a new project, let me switch now to and show you the mobile service. So when I go, okay, what you see here is now actually a mobile service. Let me switch to presenter mode. Oh, okay. Okay, I hope everyone can see that. So when I unfold the service now on this level, you can see that yeah, everyone else who has written ASP.NET applications before will see something that they can relate to. For everyone else here, I like to tell you that this is the basic structure that you get. So you have your jobs here, and this is what I wanted to say to you before when we have watched the slides. This is the project structure that will be created for each managed.NET backend service, and these are the jobs. These are some performance counters that can be used for service bus, and this is the models folder. So if we go into that, you can see the context that is used for entity framework to connect to your database, and what I've talked before about the DB sets that use specific classes that represent then your tables in the database. So what happens here also is that the mobile services the backend has specific system columns, like for example, sample updated or created and so on, that are used for offline synchronization. And what here happens in modulebuilder.add is that these table column attributes are mapped to those entities to make them available in each and every table. So this is a little bit of the detail what happens, and this is the connection string. And in every web service project or ASP.NET project, you have those connection strings in web.config, and you can see it here. So this is the connection string that will connect to the database on Azure, and we have two of them. I have one for the external database and one for the mobile services database. Then there's the migrations folder. So what we are doing here is we are using entity framework in code first mode. This means that we create those model classes. Those model classes are then added to the context. And when we do a migration, this means we change something, for example, the customer table, we change the class, and we add an additional column, for example, which is represented as a usual property or member. And we start a migration. This column will be added then to the respective table on in SQL Server, for example, on the backend. And here we have the hubs. I have created this folder. This folder is not created when you create a new mobile services managed.net backend project. I've done that, and this is the part of that Signal R is using. We need that for Signal R. And the data objects that you see here, you can see that this to-do item inherits from entity data, and if I have 12 on entity data, you can see those system columns I've talked about, updated at, created at, and so on. And those are defined in the iTable data interface, and the mobile services expect these columns to be there if you want to use or create a DTO object, this here, to-do item, that will map later to a simple Popo class on your client. Okay, it's the same class, except that it doesn't inherit from entity data. So that's the main difference. This is the difference between a DTO and a simple Popo object that you use later on your client side. And then we have the controllers. So you have to differentiate between two controller types in the management. The first controller type is a table controller, for example, which we have here. And you can see that the to-do item controller inherits from the class, from the generic class table controller, and you can see that it has the type argument of to-do item, for example, and this is, for example, created for every table you use in your managed.net backend. Okay, what you see here does not have to scare you, because when you right-click here and you say add and control, you can choose, for example, to add a microsystem, the standard tool, or in more right click add, change the model. Then you can use data class that is needed to just to take out this scary. It's not so scary. It's very simple. So you will get used to it very fast after creating some controllers, and yeah, it's working perfectly, right? And what you see here is the initialization part, and here are those CRUD functions that I have been talking about before. So here's a simple get that will get all to-do items. But you can see that it delivers, it returns an iQueryable of to-do item, which means you can use it really nicely with LINQ to filter the set that is delivered to you. And here, the next thing is you can get a specific to-do item by passing in an ID. And you can see that this is a get method. So you will call it by using get in your request. And the batch is to update the patch method is used to update your data, and you can see that inside the patch to do item, you have the update async method, which will really update your item in the database. And posting is always adding. You add a new item, and delete. Okay, this will delete a specific item. So how it works is it's very simple. It's when you have get. The system knows that you call this via get. If you see it here again, this get prefix. If you have batch, the system knows that it has to call it here. Default, the system knows that it needs to and delete. You have to do a different system and root your best and the contributions. And it updates those this is so that's about config. And so all the methods can move, for example, want to use catch the student and you want to use injection, for example, to make these particular each controller. What you can see, I have so this is all has everything so they are different it's not possible. And you hear the question. This is the data variables. So with something more for push I only so then I said that these are working with American people and speed in no for 3 without C. And here comes the part of it and the conversion and this safely the conversion of it and it's new last so this should be a professional for open data functions but we for any transform with that it's not you see people use the Azure and you will do in spot so you can see the reach map new systems so this and we also find to actually initial layer and manufacture and we have focus on cost of and so all let's see very often firstly the end user. So this is new if you different from people in the board. It's that this is with all our different versions also so they can choose to I think it's here that is our and the function in website and service. And this every website you can study and one see that work later what this looks like and it looks used to be example is also available. And you see and the organ that the process is not supporting for the center office to first to look at who and spill. So you data that and if that's the sign out is one maybe through so you can use the configuration. You can choose to remove additional files at this destination. Those are files usually that are not needed anymore, and they will be removed. And some files from the data folder can be excluded or not, but this is not relevant currently. When you click on next, you can do something like a pseudo deployment by using the start preview button. This is actually not deploying; it's only simulating the deployment process. And as you can see, there are no changes that I've made so far since the last deployment. Therefore, you don't see anything. And if I would click on publish, it would simply publish everything, but there are no changes and it will finish really fast and do nothing. So, okay, so much about this part. If you take a look at the Server Explorer in Visual Studio, you can see this entry on which is showing all your services on Azure, also the notification hubs and everything else. So if you want to use the latest tooling, I strongly want to encourage you to install Visual Studio 2013 Update 3, and then you have to download and install Azure SDK 2.4. Update 3 will not install Azure SDK 2.4, so you will not see this tooling then. You will see that this tree, but there are additional functions now that have not been available before Azure SDK 2.4. So when I open the mobile services, you can see that it will list all my available mobile services. And you can see here that I can open this in the management portal, that I can view the logs, and that I can see the properties. So if I, for example, go on view logs, you can see really nicely all the entries that have been saved to the log. So this is really nice, and it's much better readable than on the web, and it's a really nice addition. So let me show you something else in notification hubs. It always takes a while, but yeah, you cannot prepare for that. Okay, you see this hub, and usually there should be now. Yeah, you see, this is really nice. You can create your push messages and everything else now using this page. You can use a broadcast, or you can use specific text to do so. This is something that you can use with notification hubs. You can create text, for example, like customers, or for example, I don't know, salesman or something, or for example, you can create a specific tag for example, some media event that you have, and you can send those push notifications then out to receivers that have that listen to those specific tags. And the broadcast will send it to all of your receivers, to all registered devices. And you can see that you can choose lots of templates here, Windows WNS and MPNS and Apple APNS and Google and everything else. So if you choose, for example, Toast, it will create a nice looking XML file that you can use to test your notifications. That's really cool. I really like that. Okay. So this is a bit of the new tooling that is available, and I highly encourage you to check that and to check the new features in Azure SDK 2.4. And let's return now to our service. So the first thing I want to show you is we have these databases here. So let me move this window. I've connected to the Azure database using SQL Server Management Studio. You can do that very easily. And you can see when we open the LIDNUG DB demo that we have a migrations history table here. This is part of the Entity Framework migrations process. It simply creates something like a protocol of the last migrations, when the migrations have been done and so on. And we have here the to-do items table. And if you take a look at the columns, you can see that there are the system columns, updated and deleted and so on, and text complete. Those are two columns that we use in the model. So this is essentially what is created when you create your new managed mobile service. The database will be created. This is the free database that I'm using currently. It's up to 20 megs. But you can see that I have created two databases using SQL Server Management Studio. And this is the external database that we will use to insert new data into this database that is not part of the DTO system of mobile services. Okay. So, okay, you create everything, your service is created, and then the context will be created, and what you can see here, the to-do items. For example, this is a sample item that was created when the service was created. So again, every table that has to be represented in your database needs to have one class, one data object, one DTO object that is inheriting from entity data. If you want to use, for example, Azure Table Data, you inherit from table data and so on. And there are different types and ways to do that. So this is what you see in the database. Again, I can show you that window by window. Okay, this is the DB. And you can see text here and text here, complete and complete here. So this is what is created, and this is created by inheriting from entity data. Okay. So when you start the migrations process, this means when you want these changes to be reflected in a database, you need to use the package manager console, and you need to enter this statement first. Enable migrations. And this command will create this migrations folder and this configuration class. This configuration class is needed for the whole migration process, and it will allow you to have automatic migrations, which is needed if you want to have the database model updated instantly for your mobile service. And you can set that to false, and you can do it using the statement update database, which will then update your database after adding a migration. Every migration that is added using the add migration command will create such a file here. You can see that it contains a timestamp and the name of the migration after the underscore, which is initial. And you can see that there are two methods, and this class initial is inheriting from DB migration, and there's an up and a down method. So the down method will delete all the changes, and the up method will add those changes. So this is basically what happens when a migration is executed by Entity Framework. It will create a new table, create table, LIDNUG demo service. This is the namespace on SQL Server, and the table is called to do items, and it will add new columns here everywhere. You see, create that and all this other stuff. And this is what happens. And when you type enable migrations, this file is created, and as soon as you type add migration, you can see, I don't know if this is really good, readable or not. Add migration initial, it will add a new file with a timestamp and the name that you have given this migration, which is initial. Then when you change something in your model, this means you change, for example, the to-do item, you add a new column here, then you add another migration, and call it whatever you like, what you have changed. And you F5 the service, and it will apply this migration and add a column or delete a column and so on. Okay? When we go to, let me see, to this file, this is what I told you before. During development, you uncomment these lines and comment out this one. And this will apply the migration when the service is started. Or when you hit F5, the migration will be executed. Okay? So, currently we are not changing anything. So, but this is really important, and you will get all of the source code so that you can play with it and you can test it and everything else. Yeah, you have to play with that. So this is only the basic things that you need to do when you add new migration. So this is very important. So now you can start the service, for example, locally. If you fire up a web browser, let me close that. And this is where all this magic happens from on the .NET backend. So if you see the smiley face, everything is okay. If you see the sad face, something is really wrong. And as long as the service runs locally, you don't have to authorize yourself against the service to see the available methods and the available controllers. So this is a really nice part of the managed backend. You can see all your APIs, and these are the controllers that you see here. and the jobs. So let's go back first to controllers, and this is a to-do item controller that you have seen before. So this one. And if you take a look at these operations, get all to-do items, get to-do item, and so on, you can see those reflected here in the API documentation page. Get tables, tables to-do item with an ID that you pass, post, add a new one, delete, and so on. And this is the external data controller. That is a custom API controller. So, if you want to test those operations, you simply click on one. It works for a little while. It's not very long. And you can see what the response will be of this operation. This is what I mentioned before. It will deliver JSON data wherever it can. And this is done because they want to use it on every imaginable platform, and it's really easy to use. And so here is a nice button which is called Try This Out. You click on that, and you can see that it performs the get operation, and this is the route to your controller. It's a tables controller, and it's to-do items. It's the name of the controller, and the operation that will be performed is the get operation. Now you send that, and you will see a result if everything works well. So there's nothing in there in our local database, but you can see the headers and everything else, and you can see that the state is okay. So if you get a 400 or 404 or something else, that's not good, but that's okay. So this is something you need to learn about, you need to know about, and to effectively use the managed .NET backend. So after you have published the service, let me show you that as well. And this as well. And if I click this URL, you can see the live site that's running. And when you now click try it out, you will not be able to access it without a password. So the password is let me do that, is your master key. You copy that master key, and you don't need a username. So again, I simply pasted that into the password field. Click OK, and this is the live version of the service now. Okay, you see it's exactly the same like the local version, and if we go now on to do items, we can do exactly the same we have done before locally. Okay, let's try this out. Send. And you can see we have data, so it's accessing the real database that we have connected via the connection string, and it's delivering already some items to us. Okay, so much about a little bit about the environment. And as I said before, you have these controllers, the stable controllers that you use to work with your data. And you have DTO objects. And when you are using Azure Mobile Services in your client app, you have this POCO object. So let me show you that. You see there's a to-do item. And when I, for example, let me show you the first, something like, first of all,
which one should I take? Okay. Here, for example, you have a to-do item, and this to-do item is passed to a table. So before you execute any operation like inserting or updating data, you have to get a reference to this table, and this is what happens here using the client. I will go later on deeper into that, but you get the table, and then you use your Poker objects to perform these operations, to insert, update, and delete. Show your thumb. So this is what you do on the client side. And when we go back to demos, let me do the single R thing now. Let's open this up. You've seen before in the config file that we are adding the single R extension. And single R inherit from R. And the single R is basically what we did to send messages. It like this and it's messages all over the meter. So when it's for example, and use property to receive messages. I don't think that is in this station. Most of it as we had before. You the report you use to get the level for disabled, for for example, for all and so on. This is in mobile using the organization good percent, but organization that we can specially messages as you or as almost everything promoting that for the user can get for the and the messages in the to set up. That's so simply that is the call is name of the name of the guest and I'm in the middle of that is name of the just in the it's not name it's on this point behind the message. Go out and flash. You see, it's a very big this. It's that we take beyond the grid to be connected, so you don't this equals devices. It's going to be there, and even though you're not doing this, happen benefit. But so that's and this is the 4 business situations. And content using context, I stand. But we have a similar example to every single client that we have. And what I'm doing also is I'm sending a toast, push notification inside this method every time when we add a new customer in the external database. But we will come to that back later. So this is what you do on the server side. So basically you can insert this. You can grab the hub context in every single controller, and you can send out messages in real time to many clients when you execute specific actions, for example. So this is very easy to use. You simply grab the context and you send the message. So when you are working on the client side, I can show you that also. Where is it? Okay. Sorry. You can see that we are creating a new hub connection, and this connection is defined here. And we grab that connection from our mobile service. So we have inside, let me see that. Yeah, into app.sample.cs, we initialize our mobile services client. And using this client, we are grabbing the hub connection. This is the right URL to connect to SignalR. And because we have limited that to only authenticated users, no one can use that URL even if they know it to send any data if they are not authenticated against the service. So this is why we do that. Okay, so what happens here? This is also sample code that you can see within the Azure tutorials, and I've used that here. I've changed only a little bit just to make it suitable for our example. But you can read all these tutorials later, and you can see exactly what it does and everything else. I will give you a big overview about all these parts that are used in Azure Mobile Services. Okay, we have a header here, as you can see, hub connection headers, zoom out, and this is passing the authentication token from the current user that is authenticated, and it will pass the application key. So usually it is like this, that you can then say you have the authorization level to application, and only the app can access then the client. Only the client can access then the Signal R hub. Okay. So in the next line we create the proxy, and then we have to pass the name of our hub that we have created on the back end. And this class is called Message Hub. And what happens then? Signal R will create a connection to this hub, and we are able then, if the connection succeeds, to send or to receive messages from Signal R. And this part shows you how to send the message. And as you can see, I'm passing a string that tells Signal R which method to execute. And if we go back later on to our backend, you will see that the message hub has this method send, and that it has a string parameter that is the message that will be sent out. Later, when we start the app, we will see this first message, and it will display "Hello World." So this will directly be sent to our mobile service, consumed on the mobile services side by Signal R, and sent back to our app. This happens on every start of the app. Okay. And this will be displayed in a dialog. And here is the interesting thing. This means every time when somebody sends a message using Signal R and our hub, we will receive that message. And I will set the text of a specific text block to the result of that message. And what you have seen in the backend in our custom controller, when we insert data, the app will show you the last customer that was inserted. I'm generating some grid values for that, and the first name will be shown in this specific text block. Okay, so this is basically all you have to do to access the installation of your Signal R hubs on your backend service. Many people told me that this is not working, but it's working really well. And you can see that the basic demo code is working. Okay, let's go back to the service again. So, okay, you see, this is what we do. We send this message, and the client will receive this message then later on. Okay. Now, what I said before, this is the service project, and we create a separate project, or I have created a separate project that will hold all this client focus. So what you can see here is the to-do item class. This is the to-do item class that will be later on used in your clients. And you can see that this to-do item is not inheriting from entity base. Let me show you that again. It's a bit hard with only with one monitor. Here in the service. And if you take a look here at the to-do item, it's inheriting from entity data, sorry, not entity base. And the POCO, the plain old objects you use on your client side, don't inherit from that class. See that? And what is said here is something that is used later on when the data is delivered back. This attribute is simply saying that this property text is named text with a lowercase first letter, and this property is named complete with a lowercase first letter later on when the results are delivered. So, and for every DTO, you create a corresponding class in your client focus portable project. And then when you use your mobile services client
inside your client, you use these classes, these model classes, to retrieve, update, and perform other operations on the data. Okay? So, as you can see, I have this referenced here. Where is it? You see that? Let's call it again. Yes, client focus. Ah, this is not the client. Sorry. Let's see the client again. Here. Okay. You see that here. So I've referenced this project here inside the client, and yeah, this is where the client data goes later on. So when you search for tutorials on including external databases and mobile services.net, and especially the backend, you will find many things that are related to AutoMapper. And people had different kinds of problems using that. I had some problems as well. This is not, I had a forum thread on MSDN, and I could not clarify until today why it didn't work. So I'm still waiting for that answer, and there's a small tutorial that will work with a specific configuration, but many customers have told me that that it does not work if they use their existing databases and they don't know how to map them and everything else. And therefore I was thinking about another solution that could be used as a workaround until these points are clarified. And the idea is that we create a separate DLL, and we create inside this DLL again a new table context, and this table context is bound to an external database. And this external database that is not part of the Azure Mobile Services, you can see here. I have this existing DB here, and it has already existing data and so on. And when you take a look at the app.config, you can see that connection string over here. This external database connection string. I've added that, and I've added a database context, and I've added one simple model class. Okay, this is very simple, standard entity framework, nothing special. You can find that in any kind of tutorial. So what is important now is that you take the connection string from the external, from this app.config, and you copy that into the services project and add that to the web.config. You can see it's exactly the same connection string here within the connection strings section. So this is very important. Then when this DLL is compiled and ready for use, you simply reference that in your service. Let me show you that. Here, you see the external DB entry here, and this will give you access to this other database that is not part of your Azure Mobile Service, and you can still use your model like you have used it before, and you can work with this external data and pass data to your mobile services, or use custom API calls that I will show you later to access this data. Okay, so this is the basic concept. Create a DLL, create a code first model within this DLL with entity framework, enable migrations, modify your data, do whatever you want, and include that into your mobile services.net backend, and then create a custom controller. This custom controller is this external data controller,
And you can see that I'm using this external database context here. And I'm simply adding a new user, a new customer into the database. Then I'm sending this new customer number via signal R, and I'm sending a toast. So that's basically it. What happens here? It is later on when you have created your own services and you are doing your first steps, or you are trying to integrate your external database, you will get the concept very fast. So this is basically those projects are being created, and when we run now everything, because I have published the service already, and let me run that on the local machine, we see that we have authentication also inside that service. Yes, it takes a while. Okay. You see, Microsoft login is working. Now I sign in. Okay, this is pretty basic from the samples. And you can see that I have here, this is the first message that comes from Signal R, hello world. This is what I mentioned before. And when I click here on send push, for example, you can see that we get the message from Signal R that this customer has been added. Message sent by all the controller. But it does as well. So if we add, for example, another item. These are the DTOs that I use directly from the mobile service. I click on save. You can see that the item instantly pops up. And when I select an item here, it will be changed and updated. So this is basically the sample that you can see here. Okay. Now let's go to the client side and explain a little bit the code. Okay. And also the push registration and everything else. So when you create your mobile service and you want to use push notifications and everything else, you have first to associate your app with the store. This is what I have done already, and what you have seen on my Windows Store dashboard. And if you want to add push notifications, you simply right-click again, and then you say Add, and Push Notification. And this will start all this assistance and everything else. And after this is finished, you can see that there is a new folder services. This will be created afterwards with the pushregister.cs class. And this is basically how it works. It will register for you the channel, the push notification channel, for using the push notification channel manager, and it will create a notification for your application, a channel for your application. And then it tries to register the user against the push notification channel and registering the device over there on the mobile services .NET part on the back end. If that fails, it will handle the exception that occurred during the registration, and this code is added automatically for you. So you don't have to do very much to enable push notifications within your app. This works for Windows phone 8.1 apps as well. And you get a very good tooling from Visual Studio to do that. This is why I don't show you every single assistant. As soon as you use it, you will see it's very simple. And yeah, when we go now to app.saml, so what you have to do basically to use the manage.backend, the .NET backend, you have to create a mobile services client. And this is done here in app.saml.cs. And you have here a static instance of the mobile services client so that you can use it everywhere in your app. And basically you pass it the application key and the URL to your mobile service. So this is basically everything you have to do to instantiate this client. Without that client, you cannot execute any authentication tasks, you cannot modify the data, you cannot send push notifications or anything else. So, what happens here is, see that this upload channel method is called, that we have seen before, to register the push channel. And yeah, that's basically it, to wire up push and to wire up the mobile services client. When we go to the main page of saml.cs, you can see that we have a mobile services user. We use this class to check the authentication data, or like the token, for example, and the username. And we have here on the next line the mobile services collection. This is what we use to bind the data to a list, for example. And like I said before, if you want to execute any kind of actions related to a table that is based on a DTO, by inheriting entity data, you have to get a reference to the table first. Without getting the reference, you will not be able to execute anything on the table. You cannot add data or delete data and so on. And on the next line, you see the hub connection that we need for Signal R. And this hub connection enables us later to send and receive data from Signal R. When we scroll down, you see the basic CRUD operations that can be done using the table, for example. And all the operations are async. And you can see there's an insert async method where you have to pass a to-do item. This item is the Pogo class that comes from our Pogo class library. If you remember that, I said that. And you add items like this. So you can refresh the items. This is where you select all the items from the table, and you fill this collection that was defined here, and then you bind that to your list or something else. Okay? And it's very important to use this kind of invalid operation exception, because it will tell you exactly what the problem was, if you have forgotten any parameters, or if the action was not found, and so on and so on. So to update an item, it's very simple. Update async, pass the item, and yes, it removes the item then here from the collection, and this will be reflected then again on the main page. Okay, refreshing the items and so on, modifying the items. So the next important thing that I like to show you is the authentication part. So it's also very simple. If you take a look at this authenticate async method, you can see that the mobile services client instance is called, and there's the .login async method. And we are using a Microsoft account. If you have other providers like Google, for example. You can choose that here. And it will start the web authentication broker, as you have seen before, and you can log into your service. If it was successful, the code is very simple. You are now logged in. You will see this message. Otherwise, you will see you must log in, and login is required. Then again, the single connection. We have talked about that before. And here's one thing that I want to show you also. This is how we get the channel. The push notification channel to send out the push notification from your client. Okay, this is this part. This is what you have to do here if you want to do it. And then you register the channel, and that's it. And here, this is what I want to show you is how do you invoke a custom API, which is not a DTO object. You see that I'm calling the external data controller here, and I'm using the HTTP method get, and I'm not using any parameters here. You have different kinds of implementations of this method. You can pass the method type get, patch, update, delete, and so on. Or, for example, a really simple call that will always issue a post. But this is how you call a custom controller. You use the invoke API async method, and this will invoke your custom controller and the method, the action. In this case, it is get, and if you take a look again at the service part, and we go to our custom controller, yeah, here we are. You see, this is the get method, and it will call this method then. So this is basically everything that is important to know to start using all these components together. It's really a lot, and you can talk for hours about that.
Speaking of hours, Elijah, we've just hit 90 minutes there, so
yeah,
we can start wrapping up.
Yes.
Let's do Q&A and things.
Yeah. You can pass the people also to the mic if you want. They can ask directly. They can write something.
We can do that, but we try not to, because it's sometimes quite a problem and a challenge to get people's audio set up. But if anybody there's got any burning Q&A questions they'd like to ask Elijah, pop them in the Q&A window right now, and we'll see if we can get them answered.
Yes. Okay, you can start.
If you want to wait and see whether a few come in, by all means carry on with your code demonstration, and we'll give it a couple of minutes and see if we get any questions in.
Okay. So this is basically what you need to know to work, kind of efficiently with the service. But like I said, please read all the tutorials and everything else. So we will need about, I don't know, maybe 10 hours or so to explain everything in detail. It's very important that you learn about Web API, that you learn about the web.config file. As you can see all the settings here. And all these settings are installed after the deployment of the service. And all these values will be replaced by the values that you have set in the portal or you have configured and set here. So now let me show you a little bit of Kudu and what it can do, because not many people know about that you can call this Kudu URL. Let me show you that. So if you browse for Kudu and mobile services, you can see, so this is basically the Kudu GitHub website, and you can learn everything about Kudu here, okay? Kudu is used to deploy Azure websites and Azure mobile services. So you can see that the Kudu URL for your mobile service is, this one. It's yourservice.scm.azuremobileservices.net. So when I go now to my to our mobile service, and you can see this is the URL, and you can see that you have only to add SCM between everything. Go back to that because this is very interesting. So I'm already logged in with my Microsoft account, and if I add that now here, where is it? I have 2 points here. You can see that this SCM site will be opened. So this is quite interesting. So this is the Kudu site for your mobile service, and what you can see here, you can see the temp directory, environment variables, and everything else. And let me click on that, and you can see all these different settings keys that I mentioned before. And you can see your connection strings, for example, for the local. You see that? Local SQL server. This is why we had no data when we executed our controller methods on the local host. And what you can see here is the standard table connection string. You see that this is the one that is used for your mobile services backend. And you can see also the Signal R connection string and the Notification Hub connection string and all kinds of different settings. Okay, this is quite interesting also for debugging and maybe to find some errors that are not based on your code. What's very interesting is that you can execute a command shell, and this will not only allow you to execute different commands, so not all commands are allowed, but it will allow you, for example, to see your log files. And this is something that was not possible before. So if you click on edit here, for example, you can see those log files, and if we go to the mobile service and we choose the log, you can see that we have here all these entries. If I delete this now, you can do that without any problems. Go to scale and change to logs again. Yeah, you can see the logs are empty. Okay? Let me see. I see there's one question, yes?
Yeah, I was just going to say we've got one question in there. Looks like it's all we're going to get. So if you'd like to answer that one, and then we'll just call it a day there.
Yeah, so question, is it only me or is the sound extremely low? I don't know.
No. Click on the Manage tab.
Oh my god, okay. Gavin.
There you go.
Okay, thank you. I've been playing with the Node backend as I scanned it, and the net backend was not yet available. Given all the great stuff you can do to build a custom service to the net backend, does building a service with Node offer advantages over the net backend? No. I have to say clearly no. Both services have nearly the same feature sets, and maybe there's one advantage now to the Node backend, that it is stable, and the .NET backend is still in preview. So this is all, and it's quite easy also to port your existing Node.js backend to the .NET backend, because the components that are used, like the tables and everything else, and your custom API, that maps directly, for example, to controllers, custom controllers, and the .NET Entity Framework layer that you use to access your tables. So there's no major advantage.
Right, well, that certainly looks like some really interesting stuff. I've got to confess, I really do have to get into the Azure stuff. I've done absolutely nothing with it, and I really should have done by now. I've had more exposure with Amazon than I have with the Azure stuff, and I'm supposed to be a .NET person, so you know.
Yeah, that's really nice. So you can use all of this stuff, but what I have really seen is that many mobile developers have not worked with websites very much, because they are mobile developers. That's in their nature. But I think that this is actually the biggest hurdle that the people have to climb to learn about Web API. If I would explain everything in detail about Web API, about how it's used, about how the controllers work and everything else, it will take a very long time. So
absolutely.
Yeah, the main thing is that people can visit these ASP.NET Web API sites, and there are really excellent tutorials. Let me show you that very quickly.
Well, you know, if you want to, Ilyaj, what you can maybe do is come into the group during the week, into the LIDNUG group, and start a discussion going, and sort of get talking to some of the members about it.
That's no problem.
Because what we like to do, we like to encourage discussions with the members, and then that way you get like a one-on-one interaction, you know?
Yeah, that's great. I'm available, so if there's anything the people need, feel free. They should really feel free to contact me on LinkedIn and to write down the questions and everything else, and I will publish this code, and I will write an additional blog post.
Well, what I'll do, I'll start a discussion going, then I'll give you the link, and then you can come in and participate.
Yes, I will do that. Yeah? No problem. I hope it was not too complicated, and because
no, fantastic. We love the deep dive stuff. We actually don't get enough of it, but we really do love it. You know, especially when there's lots of code on the screen.
Yeah.
But I'm going to have to wrap it at this point, because we can only record for so long on the live meeting.
Okay.
It'll give up the ghost in just a moment. So I'd just like to thank you very, very much for coming along and doing this presentation for us.
Yeah, I'm really...
We will be putting this up on our YouTube channel at YouTube/LIDNUG, along with our other videos. So anybody who didn't get to see it can go and watch it later. To those attendees that are still in the audience, thanks very much for persevering with us. We're sorry about the problems we had at the beginning getting started off, but once we got them sorted, the demo God's looked favourably on us. And thanks once again for attending another live LIDNUG presentation.
Yeah, thank you. Thank you for having me, and a big thank you to all the attendees that have listened so long to me. Because, it's